Okay, welcome. Armando and Aria and Terrence and Brittany and Tina and Guadalupe and Rafael and
Madam.
Alex. Thanks for showing.
Okay, what?
Today's going to sound like a busy day, but it's actually not that bad. Today's not one of the harder days, even though we got 2 full chapters to do. But we actually don't do all of both chapters, and the chapters aren't that hard. Chapter 3 is much harder. So what we're going to do today is we're going to do chapter 4 and chapter 5. Chapter 4 is about discrete distributions. So hopefully you remember from chapter 1 what it means to be discrete. So that means you can list or itemize all of the possible answers that could come up in your survey. And chapter 5 is still quantitative, but it's the other one. It's continuous. So how do you deal with continuous distributions? And we're just going to do a few. We're going to do the easiest one to draw, and that's the uniform distribution, which we've talked about in chapter 2 already. And we're going to take a look at the uniform distribution and play around with it. We're also going to look at the binomial distribution. That's in the discrete, sorry, that's chapter 4 also. So we'll look at that, and again, we're going to look at uniform distribution and play around with that. So that's the plan for today. So let me ask you, do you have any questions? And I saw, Aria, you might have a question on project 1. This is a good time to ask. But it says in the chat at least. Give you a moment, but if you don't want to ask, that's okay too, but I'm always here to help you out and answer questions. Should we count out any outliers far away from, should we count out any outliers far away from the standard deviation? That's a good question. Okay, first thing, all outliers are far from the standard deviation by definition. That's what, and it's not far from the standard deviation, you mean far from the mean, or many standard deviations from the mean. You're not far from a standard deviation, you're far from a mean. And outliers can come about for 2 main reasons. One is you just blew it. So you asked, I don't know, you might have asked how old were you when you learned how to drive a car, and the person said 16 and you wrote 167 or something. And no, they weren't 167 years old when they first drove a car. So if the outlier is coming because of mistake on your part, then yeah, you remove it. You should, and not just any outliers, but anything that doesn't make sense. If you made a mistake or the person clearly just didn't get the question, you discard that point completely from the whole study. On the other hand, often the outliers, if you didn't make a mistake, are the most important part of the entire data. Okay, imagine your survey was collecting measurements in the area, in the foothills, to find out what the amount of gold there was per pound of soil. And you had a big outlier. Well, that's what you want, because that means that's where you're going to find gold. So sometimes the outliers are the most important part of the entire survey, but they're always important enough to include. So you don't want to delete an outlier unless it's coming from a mistake on your part. Does that make sense, Arya? Yeah, so outliers are important, and you want to spend a lot of time talking about it. You want to find their z-score. You want to talk about what the client will do, having seen that outlier. And again, it'll depend. If it was a gold mining thing, well, the client's going to mine gold right there. So it all depends what's going on. So outliers can be extremely important. In medicine, the outliers often mean someone's going to die and you got to send them to the ER. That's often an outlier. So it depends. Okay, so hopefully that answers your question. If anyone else has questions, again, this is a really good time to ask any question you might have, because there is a project, and again, you should be, definitely thinking about the project, because it is due not too long from now. Let me just take a look for a second. So I don't quote it wrong, but it's due October 13th. So that's 12 days from today. So again, at this point, you should have started. Hopefully, you better have you should panic right now if you don't have a partner. Okay, you definitely need partners. Best is 3 people. So if you only have 2, try and get a third. If somebody's been asking for a partner, please let them in if you only have 2 of you. Okay, you can't have 4. You can always split up into 2 and then try and find one more person. But 2 or 3 people. So again, everyone needs to have a partner by now. Also, hopefully most of you have already proposed your study. And I've looked at it and given you a thumbs up. Said, yeah, all you do is make this one change, it'll be great, and you do it. So you should be there at this point. And probably the data collection should happen. If it hasn't already happened, it should happen soon. So you should be collecting the data. That should be quick, actually. Collecting data is, in this case, because we only have a sample size of a little over 30, shouldn't take that long. Okay, it's the design of it and then the write-up that takes all the time. So you should make sure you have that data collected, and then you can work together and decide in your partnerships who's doing what in terms of the write-up. Make sure you read each other's pieces to make sure you're satisfied with it, because you're all getting the same grade. Any questions before I jump to chapter 4? Okay, let me ask you something. See if you remember, because this came from the first chapter of the first week of class. Is what does it mean to say discrete variable? Who remembers what it means to say discrete variable? You can either say it or post it in the chat box. Number-based is part of it, but that could be not discrete too. That's just quantitative as number-based. So for example, how much do you weigh is number-based but not discrete. But it's a good try, Amanda. Finite number, you might have the idea. Finite number of outcomes, much better. Finite number of outcomes, yeah. And I'm going to say a listable or countable number of outcomes. So you could list them in a table. And that's the important thing, is what we're going to be doing now is we're going to be thinking about discrete variables. And discrete variables are things you can list. There's lots of good examples of discrete variables. One, for example, is if I pick a card and I say, what is that value of the card? Aces are 1, and 2, 3, 4, 5, 6, 7, 8, 9, 10. Jacks, queens, and kings are all 10. What is the value? That's discrete because I can list all of the different outcomes. Okay, or I think it's, where did it go? There it is. Use these too because they're important. Rolling dice. So rolling dice is also very important. So you want to be able to understand that's discrete. If you roll 1 die, then there are 6 outcomes. 1, 2, 3, 4, 5, and 6. There are lots of discrete ones. Now, you know, up here in Tahoe, we gamble. I don't anymore, basically because I was told I can't. But so that's important. But most people are not gamblers. And by the way, it's a bad idea to be a gambler. But you might be a manager of gambling up here. That you can make some good money in. But there's other things. Discrete doesn't mean gambling. Just let you know that, just because I showed you cards and dice. Discrete can have all kinds of different examples. So things like how many siblings are in your family, that's discrete. How many pairs of shoes do you own is discrete. One nice way of telling that it's discrete is grammar. Probably the last thing you would think of. But if you ask a survey question using the words how many, then that's almost always a discrete variable. Whereas if it's not discrete, if it's continuous, which is still quantitative, then the grammar is how much. So you wouldn't say how many do you weigh, you would say how much do you weigh? And that's a continuous variable, okay? You wouldn't say, you know, you wouldn't say how much shoes do you have? You would say how many shoes do you have? So that's a nice little test to see if you have a discrete or a continuous data, is to think about the grammar. Of course, you have to understand a little bit of grammar and see if it's a how many or a how much. Believe it or not, the first time I came up with this idea is when I taught English in Japan. And I had to explain the difference between how many and how much. Okay, and then I realized, I could use that for this class, for discrete, because discrete's about how many, continuous is about how much. Okay, so let me give you an example. And now we're going to do a whole lot with it. And we're going to do stuff with the discrete distribution. So let me share my desktop. And we have a question. Okay, so here's the question. It says, a car salesperson gives out a $10 gift card or gift to every customer who test drives a car. Okay, 12% of all customers who test drive a car purchases a base model of the car, resulting in a $200 commission for the salesperson. 8% of all customers who test drive a car purchases the deluxe model of the car, resulting in a $300 commission for the salesperson. Write down the probability distribution function for the salesperson's profit, find the expected value in the standard deviation, and interpret the expected value. Is this a lucrative job? Okay, so there's a lot of questions on this one. Hopefully you agree. So what I'm going to do is I'm going to start from the beginning, and that is the beginning of the question, is write down a probability distribution function for the salesperson's profit. Because this is a discrete distribution, okay, there are not that many different choices that could happen for each customer. We can list them, and that means we can write it in a table. And that's very important to realize, is that when you have a probability distribution function and you have a discrete variable, you can always use a table. So I'm going to draw a table. Seems like the right thing to do. Okay, so notice that we have in our table, there's always going to be two pieces of the table, or two columns. You can do it in rows if you want, that doesn't matter. So the first is going to be all the different values that can occur. I call that X. In math, that's the typical thing you call a value when you don't know it yet and you want to label it. Then the second column will be the probability of that value of X happening, so P of X. So whenever you have to do a probability distribution for a discrete variable, it's always going to be a table like this with X and P of X. Then what we do is we say, what values of X can happen? So can any of you tell me one of the values, just one of the values of X that might happen? You're the salesperson. Okay. By the way, a long time ago, my brother used to do this. He used to sell used cars, and he'd get money every time someone bought one. And it was a little gift that you gave. Okay. So I'm looking at it. Tina says minus 10. So notice that the salesperson is giving a $10 gift card. And if the person does not buy a car, just walks away, which is most people, then you lose $10. Okay, then the other choices are 190 and 290 according to Arya. So notice that if the person buys just a regular old car, salesperson gets 200 but spent 10, and it's 190 left. So by the way, this is a main piece of business economics, and this is something that everyone in the world should know, and that is profit is revenue minus cost. So if you want to find out your profit, because that's the question, is what's the profit, you take the amount of money that comes in minus the amount of money that comes out. And that's your standard profit equation. And that's, you don't have to have taken a whole class in business or economics for that, but it's really important. So now I'm going to put in the different profits. And I'm going to label it as 190, 290, and negative 10. You'll see why in the order I did in a bit. You could do it any order, but that'll be a little better for this particular example. So we have 190, we have 290, and we have negative 10. Any questions so far? Okay, so now we need to find P of X. So P of X is a probability of that value of X happening. Let's start out with the 190. What's the probability that the salesperson will end up with a profit of $190? Yeah, 0.12. So 0.12, and that again, it's 0.12 because 12%, you move the decimal over twice, and that's 0.12. Okay, what's the probability of the salesperson getting $190? $290, sorry. Yeah, that's a 0.08. Now, what's the probability? Okay, so real important, it's 0.08, not 0.8, or maybe you're one step ahead. What's the probability? What's the probability of the salesperson losing $10? And that, what you do is you say, well, we already have a 12% and an 8%. So that's a total of 20% chance of selling a car. You need 100% total. If there's a 20% chance of selling a car, then there's an 80% chance, or 100% minus 20%, which is 80% chance of not selling the car, of the customer walking away. So that's going to be 0.8. I'm going to put the extra 0 in because it just looks prettier with the other numbers. Any questions so far? Okay, I'm going to write these numbers down. It's about time to get the calculator out. So let me write these out. So we have 190, 290, and negative 10. We have 0.12, 0.08, and 0.80. And now what I'm going to do is I'm going to find the expected value, and I'm going to find the standard deviation using my calculator. So let's do that. And I need to do new share, go to the calculator. And what I'm going to do is I'm going to go to stat. You're used to this. Then I'm going to go to edit. And what I'm going to do is in L1, I'm going to put my X values, which are 190. You may need to erase the first value of L1 if I'm in that column if you need to. Never delete, just erase, just clear it. And then 290. And then negative 10. Just a note, because a lot of people make the mistake of this, and it's something that I wish the calculator didn't do, but there's a minus sign net kind of the right of the 6, and there's also a minus sign below the 3. The one below the 3 is the negative sign. The one to the right of the 6 is a subtraction sign. And unfortunately, the calculator treats those differently. This is a negative 10, so we need to use the negative, not the subtraction. So if you use the subtraction, it'll actually give you an error. So again, negative 10. Any questions so far on the calculator? Okay, I always recommend that you have your calculator out and you're doing it too, so that when you get to the homework and the test, you've got it. Then what we're going to do is we're going to go ahead and go to L2, and I'm going to put the probabilities in. So we have 0.12, so 0.12, and then we have 0.08, and then we have 0.80 or 0.8. Any questions so far? All right, so now we need to figure out what the standard deviation, expected value and standard deviation are. So we're going to go to the stat button. That's our favorite button. Now we're going to go to calc, and we're going to go to one var stats. Our list is L1, so if it doesn't say L1, go second one. But now our freq list is L2. That's the frequency list. So that's second 2, enter. and then I hit calculate. If you have the older version of the calculator, then you're going to go to stat, calc, 1var stats, and then you actually type in L1, comma L2 and end the parenthesis. So the other video, my long video, has the older style. This is the newer style. Then I hit enter. Okay, it has all kinds of stuff, but we don't need most of it. We only need a couple things. Okay, the first thing is this x bar equals 38. That's our expected value. So we have to find the expected value. The standard deviation is about 98. Okay, if you want 98.47, but I'm good enough with 98. On the computer, when you have exercises to do, follow the instructions, keep as many decimals as they tell you to. Okay, on the midterm, as long as it's reasonable, I'm happy. And you've shown your work. Any questions so far? All right, so now I'm going to reshare my desktop and go back to the question, because now we have the information we wanted. All right, so here's back to the question. So we found the expected value. The expected value was 38. So first thing, this value is a money value, right? The money value is $38. Does that mean that it's most likely that the salesperson is going to profit $38 for the next customer? What do you think? Any thoughts? Yeah, absolutely not. It's impossible to profit $38 from the next customer. That can't happen. All you can profit is $190, $290, negative 10. So you got to think about, where is that 38 coming from? What does it mean? And it's not about an individual customer. Okay? Yeah, many, many. It sounds like you've been watching the video. Okay, the other video. So what we can say, and let's type this out, and I'm going to emphasize some important words. So we could say, if the car salesperson has many customers, and one many is enough, but I wanted to emphasize it in the other video with two manys. Then it is likely that the average profit per customer will be close to $38. So I want to emphasize some important pieces. The first is the word many. When you're doing expected values, it only makes sense if we're talking about many. It's the law of large numbers, basically. So if you don't have many, then it doesn't make sense. The definition of many is too hard for this class, so I'm just going to use the word many. So if you want to really learn all the details on this, you need to become a math major. And I don't think we have any of those in the class, but if we do, then you'll get to learn about it. Okay, another key word is likely. Okay, we can't say that the average customer will be close to 38 because maybe they did 100 times and they just got super lucky. Okay, but you have to, it's super, super, super lucky. So that's why the word likely. And again, the definition of likely, too hard for this class. So right now, likely is good enough. Okay, another keyword is average. Again, no individual is going to end up with a profit. No individual customer will profit the car salesperson, $38. That doesn't ever happen. But the average is likely to be, and then close to. Okay. If they had, say, 1,000 customers, that's a lot. You can talk about the average, and it'll almost never be exactly 38, but it might be $38.000001 or something. So close, good enough. Okay, you won't get exactly 38, but you're likely to average close to 38 if you have many customers. Any questions on that? Any questions on the idea? Okay. You are going to be responsible for doing this, and on the written exams especially. So if, look at what I've underlined. You miss one of them, any guess on what's going to happen? Yeah, I will take off points. Okay, so these are words you need. These are words you need. I will take off points if you miss any of these words. Okay, and by the way, if I ask you something about, I don't know, instead of cars or something, if I asked you, I don't know, about, I don't know, number of eggs that a chicken has, and you talk about a car salesperson, that's not good. So don't just like copy this. Make sure you understand it. That's more important. Okay, so that's one thing. Now let's talk about the standard deviation. Okay, so standard deviation, let me remind you, because it's been 10 or 15 minutes. So the standard deviation, let's do it in, how about purple? You've seen that same symbol before, sigma. So sigma, if you remember, was about 98. So standard deviation is has units, and it's in dollars. It's one reason why we don't use variance. I don't know if you remember, the variance is a square of the standard deviation. So the units would be in square dollars, which is basically useless. Nobody ever talks square dollars. So if in your project, if you think you can explain and interpret the variance, you're wrong. So the variance really doesn't give you any idea what's going on, except mathematically. But in terms of the idea, variance is useless. So standard deviation, on the other hand, is really important, and that's 98. Notice that 98 in this case is much bigger than 38. So what that tells you is that there is a very large fluctuation from customer to customer. So, for example, if this person did not have that many customers, the person might end up losing money at the end of the day instead of actually making money by working, and the salesperson's working. So what that would say is that you'd recommend, so since this is so large compared to the mean, or the expected value, we recommend that the car salesperson keep a significant amount of money in the bank, because there'll be days where this car salesperson doesn't make any money and you got to eat. So it's really important when you look at that standard deviation saying, yes, you're going to make on average $38 per customer, but the standard deviation is so high, in the short run, there's a decent chance that there won't be any money made. So that's why you want to make sure you have capital. And for businesses, that's really important, is that if a business doesn't have capital, then most businesses actually go bankrupt in their first year. And that's one of the main reasons why businesses go bankrupt in their first year, is that they don't have capital to handle the fact that you're losing money at the beginning. Okay, but then in the long run, think about it, $38, I don't know if anyone's been a car salesperson, but how long do you think it takes to show someone a car? You got to test drive and do this whole sales pitch. How long do you think that takes? Any thoughts? This is not a math question. This is just a reality question. How long do you think it would take to, do a demo of a car with a customer? Okay, so if it's 2 to 4 hours, okay, I think that's pretty long. Probably not that long, at least according to my brother. But if it was 2 to 4 hours, let's say 3 hours, then we're only talking about a little more than $12 an hour. Do you see that? On the other hand, if you do it in an hour, you're making $38 an hour. But it's on average. Doesn't mean it's consistently $38. It means it's on average $38 an hour. Any questions on that? Yeah, and by the way, if you're test driving a car for 4 hours with a customer, there's something wrong, just let you know. That's way too long to show a customer a car. Yeah, but not 4 hours. Not 4 hours. Trust me, if it takes 4 hours, there's something wrong. At least, sorry to my brother. That was when he was much younger, though. Any questions at all on this idea of a discrete distribution? Okay, let me talk a little bit more on more examples about discrete distributions. And this one's a little different. I have to get to it. So first thing, speak now, or you don't get to see it until you watch the video again, because it's about to get deleted so that I can get to the next one. Gone once, twice, gone. Okay, so now let's talk about another example. This one's very different with the discrete distribution. All right, so now 20% of all community college students transfer to a four-year institution. Suppose that 50 community college students are selected at random. Find the probability, let's do part A first, that exactly 10 of them transfer to a four-year university. Okay, so any questions on the question? Okay, so this is a little different. This is a different kind of distribution. So it is discrete because if we're looking at 50 students, then you could either have 0 transfer, 1 transfer, 2 transfer, etc., all the way up to 50. That's a listable finite number. Any questions on that? This is definitely discrete, but it's a very special kind of discrete. And it's special because think about the individual student's survey question. What is the survey question to that student, which you might ask 5 years later? Any thoughts? Yeah, the question itself is not if they graduate, did you graduate? Right, it's a question. Okay, and what are the possible answers? Right, actually not did you graduate, did you transfer, not graduate. Did you transfer to a four-year university? And what might be an answer to that? Let's see in the chat box or say it. Yeah, it's either yes or no. This is a yes or no question. So when you have a yes or no question that is repeated over and over and over again, and this time 50 times to 50 different people, and we have to make sure they're independent, which is pretty easy. So they're independent, which means if one person said yes, the chance of the next person said yes is this didn't get changed because the first person said yes. Again, if you did it right, then it's independent. You also have to say that that the probability for each person is the same. Okay, and the times you run into problems on this is when it takes a very long time to do a study. So for example, if the question is, do you approve of President Trump? Then if you did that over a 3-year period, that would not work because it changes from year to year. Hopefully you understand that. Okay, but if you do it right, then it's not a problem. So if you have a yes/no question that you repeat over and over again to many different people or items, then we call this a binomial distribution. So let me write that down. So this is a binomial distribution, which means that you have the yes/no question, you're going to ask to many, and you're going to count how many yeses there are. And that's called binomial. So when you have a binomial distribution, we need to identify the important variables. So the first one is n. And we've seen the letter n before, which means you might be able to tell me, what is n in this case? Yeah, n is 50, because n always stands for the number of trials, and here we're asking 50 students. So n is 50. Then we're going to have P. We've seen that letter before too. What does P stand for so far in this class? We have P for other things later. Yeah, in particular, it's the proportion or the probability of success. What's the probability of success in this case? Yeah, 0.2. So P is equal to 0.20. And then for part A, let's do it. For part A, we want the probability that X is equal to 10. Any questions on that? Any questions? All right, so now what helps me on this is I am going to go to the calculator, but before I do that, just remember, just humor me, remember that you list them in alphabetical order. And in alphabetical order, it's NPX. Y'all agree? And I think the calculator might call it R, but I think it might be X actually. So NPX in alphabetical order, and that's important. So we have 50.2 and we have 10. The other thing to note, I didn't spend a lot of time talking about, but we have X equals 10. When you have an equal sign, you're going to use a binom PDF. So let me write that down. Binom PDF. PDF stands for probability distribution function. Binom stands for binomial. And we do it in order. So it's 50, comma, 0.20, comma, 10. And just let you know, when you take the midterm, for example, if I ask you a problem like this, I want you to put this part in, because that'll help you get partial credit when you make a mistake. Most people make a mistake. So this way I can give you partial credit. On the other hand, if you just have a wrong answer, I can't give you anything. So it really helps to write down what you're doing, not just for this example, but for many examples throughout the whole course. So binom PDF of 50.210. So now what I'm going to do is I'm going to go to my calculator. And here's how I get it. First, I'm going to clear out what I had. I'm going to math. Oh, I'm sorry, not math. Made a mistake. I'm going to go to second distribution. Okay, that second VARS, and you see that DISTR stands for distribution. Then I'm going to go to, and I got to scroll down pretty far. There's a few things I wish they'd done better in this calculator, and that is binom PDF is so important. They should have put it higher. It's really low. You got to scroll a long way. And I finally found it, binom PDF, and I hit enter there. Okay, the old calculators, you type in what I had written on my little screen, which was n comma p comma x. On this, it asked you number of trials. That was 50, but it's still in the same order. P was 0.2, and the x value was 10. Any questions on that? Any questions? So then I just hit enter and paste. Okay, and again, if you have the old style, you're actually going to type that in like it's red, and then hit enter. And it's about 14% chance, 0.14. Any questions on this idea? Okay, so next, let's go ahead and reshare. And let's do part B. One of the hardest parts about this stuff is to understand the language, okay? Not the math. So part B is similarly, we have a probability. Now we have an X, and maybe you can help me out here. At most 12. A lot of people have a lot of trouble with this. What is at most 12's inequality? So what inequality do you use for at most 12? Yeah, less than or equal to. So I'm just going to type less than or equal to 12. Any questions on that? Okay, so now that I know that, I'm not going to, because it's a less than or equal to instead of an equal, it's not binom PDF anymore. It's going to be binom CDF. C stands for cumulative, which means all values up to that amount. So binom CDF still have the 50, comma, 0.20, and then comma 12. Then I go to my calculator. And I am going to go to, same idea, second distribution. I'm going to go to binom CDF this time. I hit enter on it. Same idea, trials are 50. Probability of success was 0.2. The X value is 12. And then I paste and hit enter. And that's about 81% chance, or 0.81. Any questions on that? Okay, let's try another one. How about at least 9? This one's much harder, by the way. And that's the probability of X. Now, at least, what's the inequality for at least? Yeah, this one is greater than or equal to. So one of the hard parts is you have to know what these words mean. At least means greater than or equal to. I like to remember you have to be at least 21 to walk into the bar. Do y'all agree? So, all right, you thought less than. Does that mean a 4-year-old can go to the bar and get a drink? Because that's less than 21. So that doesn't work, right? Does that make sense? Yeah. Yeah, you better not serve that 4-year-old a beer. But what about a 21-year-old? Can a 21-year-old get a drink? Okay, yeah, have to show ID, but that's okay. That's not a problem. When I was 21, it's actually the last time I got really drunk, and it was a lot of years ago because I'm not even close to 21 anymore. I don't even remember the whole day. It's, you know what I mean? I got my drink, and I was exactly 21, and that's why it's less than, or that's why it's greater than or equal to. So greater than or equal to, in this case, it was 9. Okay, the problem is the calculator can only handle less than or equal to. So how do we deal with that? And this is a little tough. Any thoughts? Okay, it's less than or equal to 8. We'll get there, but it's not quite that. We need to use the rule of complements. So what I like to do is I like to just humor me for now. I'm just going to write in some numbers. The numbers are around 9. How about 7, comma 8, comma 9, comma 10, comma 11. Maybe I'll even throw some dot, dot, dots before the 7. All right, and let's circle at least 9. So if you circle at least 9, that's those guys. Is that clear? Oh, you can only see the calculator. Thanks for telling me. Sorry about that. Forgot to do the reshare. You'll get to see what I just wrote in a minute. All right, so I'll let you, so notice I wrote probability that x is greater than or equal to 9 is equal to. Then I wrote 7, 8, 9, 10, 11, and I circled, as best I could, at least 9. And what we're going to do is we're going to use the rule of complements. So we can say, okay, by the rule of complements, is that whenever you're finding a probability, that's the same thing as doing 1 minus the probability of the complement. Now the complement we need to write as x is less than or equal to, because that's what the calculator can handle. So now, if you look at what's in my circle, the complement is everything that's not in my circle. And that's the value is less than or equal to what? 8, exactly. And now we can use a calculator. So it's 1 minus the probability that x is less than or equal to 8. Now I go back to my calculator. And I'm going to type 1 minus. I can go to second distribution. Scroll down a whole bunch. To binom CDF. And the nice thing is it remembered. Trials that. We want less than or equal to 8. And I can go paste it right in. And there we have it, about 69% chance. Any questions on this? I want to do one more that's not on the screen, actually, but I just realized that a lot of people have problems with it, so let me do that. Let's go there. So let's do a little typing. So instead of this, let's say between. How about 6 and 11 of 6 and 11, including 6 and 11 of them transfer. Okay, that's a little harder. Okay, so how do I do between 6 and 11? So I'm going to erase a few things because I need some space. Hopefully that's okay. Let's erase A and B. We don't need that one anymore. I don't want crop, I want select. There we go. Okay, so I want to go between 6 and 11. So I'm going to just do some writing, just like I did before. About 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I went between 6 and 11, including 11. So what I'm going to do is I'm going to draw a circle around all the way up to 11. Now, is that between 6 and 11? Did I just circle the numbers between 6 and 11 only? No, I got too many circled. So what I need to do is I need to take away some others. I need to take away all the numbers five and below. Any questions on that? So what I can say, let me get to, is that the probability that 6 is less than or equal to x is less than or equal to 11 is going to be equal to the probability that x is less than or equal to 11 minus the probability that x is less than or equal to what number? This is where you got to be careful. Yeah, less than or equal to 5, because you got to see what we had to take away. We're not taking away 6. We're taking away 5 and below. So less than or equal to 5. I'm not going to do the calculator part of it because that's not any harder than what we've been doing. But what's hard is to turn these words into the right inequalities that work in our calculator. Any questions at all on these examples? Okay, so I'm going to get rid of this now. If it lets me. Come on. Last chance, about to disappear. Gone. Let's do another example. This example is going to be very different though. Okay, so here's the question now. Suppose that the time that students spend in the Math Center is uniformly distributed between 10 and 120 minutes. If a randomly selected math lab user is observed, find the probability the student will spend between 30 and 70 minutes in the lab. So the first thing, is this a discrete distribution? What do you think? I don't see you all jumping in, but hopefully you can tell me. Is this discrete? Yeah, this is not discrete, okay? You would say, how much time did you spend in the math lab, not how many time. So this is a continuous distribution. This is very different. This is a uniform distribution. We cannot list all the outcomes. It's not possible. But what we can do is draw a picture. So when we have continuous distributions, we draw pictures. So let me draw a picture. And the nice thing is the picture is a rectangle. Okay, so when you have a uniform distribution, that means it's flat. You have the same probability for any equal length interval within between 10 and 120. So let me write down 10 and 120. We need that. And the definition of probability when we're talking about the picture is the area between the values you're looking at. So in this case, it's between 30 and 70. So let's write those down. That's somewhere around here. Actually, let's make those red. And then if I draw my area, oops. You have to pretend those are straight lines. Between 30 and 70, it looks like that. All right, so in terms of this area, what shape is it in one word? You should all know this. This is not supposed to be hard. Yeah, this is a rectangle. It's a rectangle. And I'm hoping that you all remember the formula for the area of a rectangle. A for area is, how do you find the area of a rectangle? The length times the width. Exactly, Raphael. I like to use base times height. The only reason I like that better is that L looks too much like a 1, so it can be confusing me. Or capitals are good too, Terrence. I'm going to use base times height if that's okay. But it's the same thing. Base times height. And there's the area of the rectangle. All right. The base we can get. The height's going to take some work. We need to find the height of this rectangle. And notice it's not shown on the diagram. But I can use something. What's the probability that if I randomly select a user, that they're going to use the math lab between 10 and 128 minutes? 10 to 120. What's the probability of that? The hint is it's easy. 100, actually, probabilities cannot be bigger than 1. And 100 is bigger than 1. Yeah, but we don't want percents. We want numbers. Yeah, 1. So the probability is going to be 1. So we know also, at least for the whole rectangle, the area is the base times the height. And for the whole rectangle, that's going to be the base is going to be 120 minus 10. That's how you find the base. The height, we don't know. That's h. But it's supposed to be equal to 1 because that's the probability. So we need to do algebra. Whether you like it or not, we have a little algebra in this class. And how do you get h by itself? Any thoughts? It's basic algebra. Yeah, we divide by 120 minus 10. And hopefully you can do that. What's 120 minus 10 is 110. So I'm going to divide each side. Oops. by 110. So I get h is 1 over 110. Any questions so far? So now I can find the probability, let's do that, that we're between 30 and 70. One nice thing about continuous distributions is it doesn't matter whether you use a less than or a less than or equal to, they're the same because there's a probability of 0 that you get exactly a number when you have a continuous distribution, because the area of a rectangle with 0 base is 0. Okay, so this probability between 30 and 70 is the base times the height. The base is 70 minus 30. And the height is 1 over 110. Any questions on that? And there's lots of ways of doing this. 70 minus 30 is 40. 40 over 110 is 4/11. I'll just leave it like that. Sometimes you want a decimal. Whatever the computer asks for is what you should put in. Any questions on this example? Okay, now I need to find the first quartile for the time it takes students to spend in the math lab. What's the definition of the first quartile? See if anyone can tell me. What about 0.25? So 25% something. So what is that? Any thoughts? Yeah, 25% of the area to the left. So what I can say is that I have this value, which I don't know what it is yet. And if I look at the area to the left, I get 0.25. Any questions on that? All right, so now what I can do is I can put that together with my ideas of area. So I can say 0.25 is the area, which is the base times the height. I don't know the base. So if you don't know the base, and we don't know this value, you give it a letter. And in math, the letter that we give something when we don't know it is X. Hopefully you know that. So I'm going to call that value X, which I don't know, but I can find it. And that's my goal, is to find that value of X so that the area gives me 0.25. Notice the picture. Diagrams are really important. So that tells us 0.25. Now we can use that X and say, well, that should be the base times the height. To get the base, we're going to go X minus 10. That's how you find the base. Just like we found it as 70 minus 30, or we did 120 minus 10, depending on what our picture was. The height is 1 over 110. We already figured that out. And guess what our goal is? What are we trying to find? Yeah, we're trying to find X. So to find X, we need to do algebra. To get X by itself, if we have X minus 10 times parentheses 1 over 110, we first multiply by 110. On both sides. Any questions on that so far? Okay, and now what we get is x minus 10 is equal to 110 times 0.25. What's 110 times 0.25? Okay, you're welcome to use a calculator, by the way. What's 110 times 0.25? Yeah, 27.5. That's what I get when I do it in my head. But I don't ever trust myself when I do it in my head. And now how do I find x? What's the last step? Yeah, we add 10 to both sides, and we get x equals 37.5. Any questions at all on finding the first quartile? I just want to let you know that when you have to do this on the exams, the written exams, if you do not draw the rectangle with all the shaded in parts, then I will take off points, a lot of them. So that's a big part. And if you draw the rectangle correctly and do everything else wrong, I'll give you points. So you'll at least get partial credit. But that is part of the question that you have to do. And it's called the uniform distribution chart. Any questions on this? Okay, I'm going to erase this, so let me know if I can't, but I'm going to. Going once, twice, got it. Okay, one more question. Actually, before we do the question, this is a good time for this. Let's do a secret word. And the secret word is many. I think Tina actually put that in the chat box at one point because it's really important for understanding the expected value. That's a secret word. And hopefully you jotted that down because I'm about to get rid of it. So the secret word is many. So make sure you write that down because it's about to be gone. Okay, now that we are ready for our last example. Last example is going to be different than the ones we just did. All right, so here's our last example. So suppose that the number of ounces of water that people drink from the drinking fountain is uniformly distributed between 1 and 8 ounces, and that the number of ounces of water that students use to fill their bottles in the drinking fountain, and I used a drinking fountain to fill my bottle, is uniformly distributed between 4 and 16 ounces. You watch Thorne take a 2.5 ounce drink out of the drinking fountain, and Preston fill his water bottle with 5 ounces of water before he runs off to class. Whose water usage is more unusually small compared to the rest of the people who use the fountain for the corresponding water usage? So let me ask you something. We've seen this word, unusually small. When you hear that word, what should you be thinking about? You want to find out how unusual something, a value is. Outliers, yeah, but I'm thinking something different. Any thoughts? Outliers are unusual. Mean standard deviation will be part of what we have to do, but something specific. Frequency, not quite. All right, I think I'll tell you, z-score. Okay, so I'm thinking about the z-score. Z-score is a measure of how unusual something is. So what we want to do is we want to find the z-score for Thorn and the z-score for Preston. And the higher z-score will be the more unusual, or the farther away from zero will be more unusual. Any questions on the idea there? Okay, so to find the z-score, you need to find, as Tina said, the mean and standard deviation. This is going to be a formula. And let me actually think I need to do it with brushes. So this is an important formula, the mean. Is equal to A plus B. That's a long B, sorry, over 2. So that makes sense. The mean is just the average of the left and the right, because the mean, it's symmetric, so it's just the median. Add them up, divide by 2. Okay, the standard deviation won't make any sense to any of you. The standard deviation is going to be the square root of B minus A squared over 12. Okay, and the only way I can explain that to you is if you take an entire year of calculus with me. Then I'll explain it to you. Most of you don't want to do that. But can you trust me that this is true? And even more important, can you remember to put this on your note sheet so that when you take your midterm, okay, and your final, these are on it and you've got some formulas. You know, you don't have a lot of space in the note sheet, so you write them small. So these are 2 important formulas to have. The mean you may have memorized, that's just the average of the left and the right. But the standard deviation is just a formula to memorize. Okay, and it's not like the calculator has it, so you need to get it. Any questions on this? All right, so now we need to find the important values for Thorn and Preston. Let's start with Thorn. So let's go to Thorn. I'll do Thorn in blue. So Thorn. Well, what is A for Thorn? What is A for Thorn? It's a good try. 2.5 is important, but it's not his A. It's his something else. What's A? The key is A is taking a drink out of the drinking fountain. Five? No, it's not 5 either. 5 has to do with Preston, actually. Okay. The key is you got to read it from the beginning. Suppose the number of ounces of water people drink from the drinking fountain is uniformly distributed between 1 and 8 ounces. So what's A? A is 1. B is what? Is 8. Oops, 8. X is 2.5. Any questions so far? All right, so now we can talk about Thorn's mean. I'm going to just say mu. Mu is a plus b over 2, which is 1 plus 8 over 2, which is 4.5. Sigma, okay, is messier. So that we have to do in a calculator. We're going to have a square root. I think I need to do it with a pen. I can't type it out. Oops. There we go. Square root of b minus a squared. Well, b is 8, a is 1, so that's 7 squared. Over 12. All right, what's the square root of 7 squared over 12? And I can't do this one perfectly in the head. Let's see if you guys can do that. I can do it approximately, so I'll know if you get it right or not, or get an idea. 2.02. That sounds right. Oops, I forgot. Hit the T button. There we go. Okay, now you got to remember that the z-score, actually, let's do this in red. Z is going to be x minus mu over sigma. That we had a while back. So now we just take x minus mu over sigma. So again, x is 2.5 minus mu, okay, and mu is 4.5 divided by sigma, which is 2.02. And that's about -1. Any questions on that? Okay, next, let's do Preston. Okay, what was Preston's A? So what's Preston's A? Preston's X will be 5, but what is Preston's A? Not a 1. Preston's using a water bottle. That's a hint. 4. Because a water bottle, it says, is uniformly distributed between 4 and 16. So that's going to be 4. And then B is equal to 16. And then X is equal to 5. Any questions on that? Okay, so now we have mu is equal to a plus b over 2, which is 4 plus 16 over 2, which is 10. We have sigma is equal to, that's the mass. I think I'm going to use, just to go fast, SQRT for square root of, well, it's b minus a, 16 minus 4 is 12, squared over 12. And what is that? Okay, that's the same thing as square root of 12, by the way. It turns out. What's the square root of 12? 3 point something. 3.4, I believe it. Okay, so then we can get the z-score. Z is equal to x is 5, minus mu, which was 10, all over 3.4. And what is that when you put that in a calculator? $3.46. Oh, 3.46 was the 3.4. Negative 1.47. All right, now we're ready to answer the question. It was a lot of work to get there, but whose water use was more unusually small? Thorne or Preston? Yeah, Thorne. Wait a minute. Which one's farther from 0? The z-score for Thorne is negative 1. The z-score for Preston is negative 1.47. Preston is more unusually small. Any questions on this? Any questions at all? Okay, we had a lot of different things to do. Most people find this easier. Just to let you know that we don't do all of chapters 4 and 5. We only do some of it. Maybe I should mention that. Let me go grab it. And let's do a new share. Show you something so we can talk about it. Where is it? That one. There we go. Okay, so in particular, if we go to the book, that's what I want to show you. So this is one of those chapters or two of those chapters we don't do the whole thing. And if we go to contents, let me show you what we do. Go to chapter 4. So we do probability distribution function for a discrete random variable that we talked about. Mean and expected value, we definitely do. We do binomial. We do not do geometric. We do not do hypogeometric. We do not do Poisson. And the others are just examples. So pretty much we do sections 1, 2, and 3. Okay, you're welcome to read the rest, but you're not responsible for it. In chapter 5, we do continuous probability functions and the uniform distribution, and that's it. We don't do the others. So you need to know those two. Okay, so hopefully that makes sense. So that's why I could put 4 and 5 in the same week, because we really do half of each, and that makes one chapter. So that's about all I have to say about this particular chapters 4 and 5 in this week. Next week will almost certainly be Monday night, by the way. Turns out I have something on Tuesday, which I am not going to be able to make with you guys. I'll be actually not working on Wednesday, a week from Wednesday. So it will almost certainly be Monday night. at like 6 o'clock or so. At least I think so. Yeah, 6 o'clock. Yes. So just let you know, I'm usually flexible, but sometimes I'm not. These last couple were a little different. So what I will do now, as I always do, I think I'll even stop the share, is I will be happy to go ahead and answer any questions you might have. So if you have questions, this is a great time. Tina, Armando, Donald, Guadalupe, Terrence, Rafael, Alex, Ellen, Trevor, Constance, Brianna, Warren, and RJ. So if you have any questions, it's a good time. If not, we can say goodnight. But always happy to answer questions. And you can talk.
On the equation where you had
I can't hear you very well. I need the volume up, I think. Let me put mine up. Try again.
earlier when you were talking about the probability of less than or equal to 6 or x being greater than or equal to 6 but less than or equal to 11, is that, do you do the two separate equations and then subtract them?
Yeah. Yeah. So I had that. It's no longer there because I had to erase it. But you need to subtract because from 6 to 11 is the same thing as everything under 11 minus everything 5 and below. So 11 below minus 5 and below. Does that make sense?
Yeah.
That's a reason why you do the subtraction.
I thought it was two equations, but I just wanted to make sure because you kind of...
Yeah, it's two terms. And maybe that's what you're thinking. So it's two terms, but it's only one equation. Does that make sense?
It's only because the final equation gives you the answer, but there's two parts to solving it.
Exactly.
Okay.
Yeah. That's a really good question. And I will tell you the reason I did this is that last quarter, everybody was confused because I didn't do an example. So I figured I better do an example because at least I got a shot that you might be able to get it when you do it on the homework. Okay, so Alex and Constance, have a good night. I'm happy to answer any other questions you might have.
On the last one that you just showed us, the sample between, I think it was between Thorne and Preston, you defined it as more unusually small, was the answer we were looking for.
Right.
And you said that was further, a z-score being further from 0 makes it unusually small?
Right. So further from 0 makes it unusual, negative makes it small. Okay. They were both negative, right?
Yeah, they were both negative.
So negative means it's small, and unusual means it's far from 0.
So if it was away from 0 but a positive number, then it's a large number.
Yeah, then it would be unusually large.
Okay.
Do you see? So negative values mean below the mean, so we call that small, right? If somebody is below the mean in height, they're short, right? Does that make sense?
Yes.
And their z-score will be negative.
Okay.
Because x minus mu will be negative, because if x is smaller than mu, x minus mu is a negative number.
So a positive z-score is a large number.
Right.
And then a negative z-score makes it unusually small.
Exactly. And the word unusual means far from 0. So very unusual would be like -4 for z or +4 are both very unusual. -4 would be very unusually small. +4 would be very unusually large.
Okay. So if it's less than, if the variance from 0 is 4 or less than 4 rather, either direction, then that's just unusual. If it's
4 is outstandingly unusual.
Okay.
Because remember, 2 is 2. I was doing 4 just to like give you an example. 2 is an outlier. 3 is extreme.
Is that because these are the standard deviations or
Yeah.
Okay.
Okay, I got a question from RJ. I'm not sure why private, because I want to tell everybody anyway. Is uniform the same as normal? Absolutely not. Uniform, remember, is a rectangle when you draw a picture. Does that make sense? Normal, what's the picture? What's the shape look for normal? Yeah, bell-shaped, which is definitely not a rectangle. Right? I've never seen a rectangle bell. We will spend all of chapter 6 and all of chapter 7 and most of the rest of the course on normal. So just because we haven't talked about normal in terms of continuous distributions does not mean it's important. It is the important piece of the whole class. We're just not there yet. So that'll be next week's lecture and the week after, and pieces of all the rest of the weeks. Whereas uniform, we're done after this week, other than tests. We won't talk about uniform again. That makes sense?
Okay.
Other questions? These are really good questions. Any other questions? Always happy to answer questions. So Tina, Armando, Brianna, Guadalupe, Warren, and RJ. You're all being kind of quiet.
I think I'm good. Have a good night.
Okay, have a good night, Tina. Yeah, we'll have a whole long lecture on just what the midterm's about, but much later. It's not for a long time, so it's too early. And there's already study stuff if you go to week 8. So it's really too early. We're only week 3. But if you go to week 8, that's when the midterm is, and there's lots of study stuff for that. And I'll be talking about it much later. In week 7 is when I'll talk about it. So it's almost a month from now that we'll even talk about it. So we will have a study stuff. I don't know if guide is the right word, but lots of study materials. Okay, Armando, any questions?
I'm okay. I took all the necessary notes.
Oh, great. Okay, Guadalupe said goodnight. Thank you. Brianna said goodnight. Warren's, any questions? And RJ? If not, we'll call it a night. Okay, so for all of you watching this as an archive webinar, thank you for watching. Don't forget to be working on the project and posting on the project discussion forum. And don't forget, Thursday is when the posts for this week must be done without losing points. I just graded today the discussion posts, and a bunch of you were after Thursday and I had to take off points. And I don't like taking off points, but posting on Sunday is not a good idea because I'll take off a bunch of points. So don't forget, Thursday is when it's due. I'll give you a reminder on Thursday, but I recommend posting it by Wednesday so that I can give you feedback. Because that's my thing is I'll give you feedback if it's posted by Wednesday before you lose points. So I'll say goodnight to all of you and just post on the Q&A forum if you have any questions about the class, and project discussion forum if you have any questions about the project. So have a good night.
Thank you.